Hello! Welcome to a video about keyboard input. So, along with the mouse, the keyboard is kind of, I guess, one of the major ways that we provide input to a program. And the same is true of P5 programs. This is obviously, generally speaking, true of desktop computers and laptops, not of mobile devices, which use touch input. That's a story for another day. The keyboard, though, is a really interesting input device for a few reasons. One of the most obvious reasons is that we use keyboards to type things in, right? Often to write language, which means that we can express thoughts with typing. We can write things with typing. We could write our name, or we could write a short story, or what have you. And so being able to accept keyboard input in our program enables us to accept language as input into our program. That opens up a lot of possibilities. In a sort of more simplistic view, you can just see the keyboard as a whole lot of buttons. There's lots of buttons. You can press the individual buttons, and each of those buttons could do a different thing. It doesn't have to be that the S key means that you type the letter S. It could do something else, like S for save the world or something, or S for somersault. We don't know. So they're buttons. We can do things with buttons. That's a good thing. And just as a very specific example of the buttons, keyboards most often have arrow keys, right, that have little arrows on them. And this is a great mapping from pressing a key to some idea of the space inside that we're representing in our program, most obviously for movement. So how do we deal with the keyboard in P5? Well, it's pretty similar to how we deal with the mouse. Most often, or at least a very common thing that we do when we're dealing with the keyboard, is that we want to respond when a key gets pressed down. So let's look at that case. Let's go over to writing a program world. In the interest of simplicity, I'm going to have a variable that controls the background color of my program. I'm going to obviously create a canvas because I love creating canvases. Do it every day, 5 times before breakfast. And in the draw function, I'm going to set my background color /shade to whatever is in the background variable. So currently we just have a program that has a black background, right? Because BG gets set to 0 right at the beginning. And if we go and look at the program running, hey presto, a black background. Now, just like with the mouse, we have specific functions that we can use to respond to events that take place with the keyboard. And one of those events is the event of the key being pressed, and that is a function called Keypressed. Again, although we've been defining our own functions a lot in this sequence of videos, function Keypressed is one of those functions that P5 already knows about. So it's a function that will be called whenever a key does actually get pressed down. So we know that this function, the instructions in it will happen when a key is pressed. So what could we do? Well, we could do something in there to do with the background. And for now, let's just set the background to a random, between 0 and 255, a random shade of black and white. So each time the key is pressed, Keypressed, the function gets called and it executes this one instruction which changes the background to a random shade of gray. So if we go back and look at our program, it starts off as black, and then if I press a key, I'm pressing the J key for what it's worth. Press, it changes the shade, press, changes, and so I can use my key to control the background to a limited extent. So key pressed is being called every time I hit that J key. That's something, but it's pretty limited, and the most obvious question that we're going to want to answer is which key got pressed, because if we want to react to different keys differently, we're going to need to know which key it was. And so that's a very important thing that we need to know when we're dealing, particularly with key pressed, but also in any situation with the keyboard, really. And there are 2 variables. Let's just get rid of this background thing for now. There are 2 variables built into P5, built-in variables, that can tell us which key was pressed. And let's write a little program that will actually display them. So the first variable is just called key, K-E-Y, and inside the variable called key will be literally the character that just got pressed. So if I press down on A, then key is going to contain A. It's going to contain specifically a string with A. So let's display it so that we can actually see what we're talking about here. So we're going to set up some text. We'll make it a bit bigger so that we can see what we're dealing with here. and we'll fill it with white since the background is black. So inside the key variable is the key that got pressed. So if I display the key variable, and I'll display it in the center of my canvas, I'm trying to remember to be a bit better about using the variables there. It's going to display whichever key was pressed because this special key variable here contains the last pressed key. So if I head back to my program now, right now no key has been pressed, so it's not showing anything. But if I press down on the Q key, then we see Q. If I press down on the P key, we see P. If I press down on 4, we see 4. If I press down on ampersand, we see ampersand. And you saw there as well that it's also printing out shift, right? Because I pressed the shift key in order to type my ampersand. If I press control, it says control. If I press option, it actually says alt, and so on. That is how the key variable works. It always contains the last key that you pressed, the most recent key that you pressed. So you can see, for example, if I press the K key, the program is still displaying the K in the key variable because it was the most recent one. So it's still inside the key variable. It doesn't shift to being undefined if no key is pressed down, which is generally speaking kind of useful. Okay, so with the knowledge that we have this variable, meta is what it calls the command key, by the way. We have this variable called key. The most obvious thing that we might want to do in this situation is in Keypressed, we could check which key got pressed and react in different ways. And how would we do that? How would we react in different ways depending on the key? We would need some if statements, right? So we're going to have an if. And what are we going to check? We need to check what's inside the key variable because we know that that contains the key that was last pressed. And we're going to check, does it equal? And then we can say, does it equal A? So here I need the string containing the letter A, right? Because the thing that's inside this key variable is a string with the character that got typed in a string, right? So here, when we're comparing it with something, we have to compare it with a string that contains that character. So this is how I check if the key pressed was the letter A. If it was the letter A, I could set my background to a specific shade. I could set it to black if they press A, and then I could have an else, and I could check if the key pressed was B, again in a string, and I could set the background to a halfway kind of a shade, 127, and otherwise, if the key pressed was, you guessed it, C, I could set the background to white. Okay, so now our program can actually react. And I guess I'll get rid. Well, no, I'll leave this stuff in for now. Now my program can react when a key is pressed, not just to the fact that any key was pressed, but that a specific key was pressed. So if the key was equal to A, we get a black background. If the key was equal to B, we get a gray background. And if the key was equal to C, we get a white background. If any other key was pressed, like W or 5 or something, the program's not going to react because that doesn't. There's nothing inside Keypressed that checks for any other key except for those 3. So if we go and look at our program again, if I press A, we get black, obviously, which it already was. B, we get gray. And C, we get white. We don't see the letter C because now it's white and the background is white. So A, B, C. B, A, C, A, B, etc. So that's what the key variable does, and that enables us to check which key was pressed so long as it is one of the sort of keys that you would normally type. Now, we did see, for instance, that on my Mac, when I press the Shift key, inside that key variable is the word Shift with a capital S. And if I press Tab, then inside the key variable is the word Tab with a capital T. And if I hit, I don't know, the space bar, then we see nothing because there's a space character in there. If I hit Option, it says Alt, etc. The fact of the matter is that it's not actually super reliable what word is going to be in the key variable for those special kinds of keys. So it's a little bit less reliable to use the key variable to check special keys. So for that kind of thing, when you really, really want to get specific, there's another variable. And that other variable, I'll just get rid of this stuff here, is called Keycode. So K-E-Y-C-O-D-E, written like this, Keycode. And Keycode is just another variable, and it contains a different representation of the key that was just pressed. Let's go and look at it, since now we're going to be printing it out again. So if I press the A key, I see the number 65. B, 66, C, 67, space, 32, Option, 18, Shift, 16, 0, 48, etc., they feel like they have no correspondence whatsoever, and they're sort of not super reliable. It doesn't make sense in a human way. These numbers that we're seeing are from what is called the ASCII character set. And what the ASCII character set does is it associates every typable character on your keyboard, as well as some special characters like various command keys with numbers. So inside Keycode is a number that represents the key that was pressed. Initially that seems kind of irritating, and certainly it is irritating if you have to remember all of these numbers. There are very good websites. One of them is called keycode.info, like that, keycode.info. And you can use this to check what specific keys are if you find that you need to know. So if I hit space, I see that space is 32. If I hit Q, I see that Q is 81, etc. So if you do need to look it up dynamically, something like keycode.info is a good place to find those key codes. You can also, as you can see up here in the top right, you can get a table that lists all of the ASCII key codes and the letters that they correspond to. What Keycode is really good for, though, is for detecting those special keys that don't have obvious representations in text. So, for example, and one really good thing I should say about, well, let's take this one step at a time. So let's do something else. So in Keypressed, let's say that if the key code is equal to, now I want the up arrow key code, so I'm actually going to go back to keycode.info over here. I'm going to press the up arrow, and it tells me that it's number 38. So if the key code is 38, which is the up arrow, then I'm going to make the background shade go up. So I'm going to add, 10 to the background shade. So if I press the up arrow, the background is going to get brighter. And I'm going to also just quickly constrain that. That's weird. Constrain that to be between the normal color range, just so that if I press up lots of times and my background color becomes, like 500 or something, that's kind of meaningless. It may as well stay within 0 to 255. And vice versa, if I press the down key, so else if keycode is equal to, now what's the down key code? Well, I don't know off by heart. That would be perverse and nerdy of me. I press down, it turns out that it's 40. There's no real way of predicting that. It's 40. Then I'll do the opposite. I'll make BG go down by 10, and I'll constrain it in the same way. BG 0 to 255. So now we're using Keycode to check the arrow keys, which is good because there's not an obvious way that we could use key to do that. We would have to match something like left arrow, but as I said, depending on the computer you're using, it's not reliable, so you can't really predict as easily that it will work on everybody's computers. The ASCII key codes, like 38 and 40 here for the arrow keys, they are very predictable. They're kind of locked. They're written in stone, so you can rely on that with your key codes. So if I head back to my program over here, if I press up, you can see the background is getting brighter because it's adding 10 to the background shade every time I press up. And if I press down, you can even see that I'm pressing the 40 key, which is the down arrow, heads back down to black. Now, this is fine, this works, but it does rely on us knowing the key codes 38 and 40 for those particular keys. P5, and you can look this up in the documentation for the key code variable, has special names for a bunch of the special characters. So we can actually, in fact, write up arrow like this, and that will tell it number 38. The number 38 is stored inside this, this variable. It's actually called a constant, but it's storing the number 38, and same for the down arrow written exactly this way, down understroke arrow, all in caps. This way we don't have to remember the specific key code. And our program becomes a little bit more readable, right? If key code equals up arrow, do this. Else if the key code is the down arrow, do this. It still works in exactly the same way, right? It's still 38. That's really the number in there, and still 40 if I'm going down. But this enables us to write sort of more comprehensible programs. So Keycode is particularly good for the situation where we want to check special keys like Shift and Control Option, Command, the Windows key, those sorts of things. And then key is better if we're wanting to check which character was just typed. There are other event handlers, so Keypressed is the one that gets called at the moment that you press a key down. There is also key released, which gets called at the moment that you let go of a key. You can do stuff with that as well. And there's also another one called key typed, which is interesting to look at. I'm not going to cover it here, just because it leads to some complexities I don't want to talk about. The good thing about key typed is that it only gets called when you hit a key that can be typed. So for example, if you just hit Shift, key typed won't be triggered because Shift is not a key that you type. But if you hit Shift D, for example, to type a capital D, then key type is called and key will be set to the capital D. That's particularly useful if you're wanting to handle typing-oriented kinds of programming. And I've got examples of that if you want to go and look at those later on. Okay, so those are the big three keyboard handling events. There's key pressed, which we've been using, key released, the same but when you let go, and key typed, which is more specifically about typing as an activity. So let's get rid of that now and talk about the other part of this. And I believe I can probably just get rid of this stuff here as well for now. So we'll leave the BG background alone. So the last thing that I want to talk about with the keyboard is actually it's a function that you call rather than a function that you define. There's a function that we can call to check whether a specific key is currently being pressed. And that can be very useful inside our draw loop. Because sometimes we want to know, is the J key being pressed? Is the up arrow being pressed, etc. And then react accordingly to that. And that function is called keyIsDown. KeyIsDown, written that way. And in the parentheses, we have to specify which key do we mean, and we have to write the key code. So it's a number, right? Or it can be one of those things like up arrow or left arrow or down arrow, etc. So just to show this in use, let's display two different shapes depending on which key we're holding down. So again, because we're trying to make a decision based on which key is pressed, we need an if statement. So we say if, and then we need to use this keyIsDown thing. So what keyIsDown looks like is this. KeyIsDown, and then we tell it which key we mean. I'm going to say 65. That's the code for the A key. So if keyIsDown and we give it 65, what that's going to do is it's going to go away and it's going to check, is the A key currently being pressed? If it is being pressed, then keyIsDown is going to return true. So it's going to be true and our if statement will succeed. And if it's not being pressed down, then keyIsDown is going to return false and our if statement will not succeed. So if keyIsDown, number 65, we have to just know that that's A. Then let's draw a rectangle. So rectangle, and we'll just draw one. I'm just going to move through this quickly, so I'm going to be a bit bad and just use numbers here. So if the A key is down, let's draw a rectangle. So let's go and look at that right away. So there's nothing because I'm not pressing the A key. I can press various other keys. I just pressed K, but nothing happens because my program doesn't care about the K key. But if I hold down the A key, A, I'm holding it down, the rectangle is there, right? Because keyIsDown is returning true for the A key because it is being held down. But if I let go, it disappears because now keyIsDown is returning false for the A key. So the rectangle is only being displayed while I hold down the A key. If key is down, then it displays the rectangle. If key is not down, it does not for the A key. Okay? So it's a way of making something happen kind of over time based on holding down a key rather than just the moment that you press a key, which is what Keypressed does. This specific example of just do I display a rectangle or not is not super, I mean it's a good illustration of what the function does, but it's maybe not the most useful. So let's quickly pop back over and do another little, here's something I prepared earlier. So I'm just going to replace this code with a fair amount more code. So let me just talk you through this very quickly. So we've got a standard circle, it moves, or it has the capacity for movement, I should say. You can see it's not moving at the beginning of the program, has a velocity of 0. We create a canvas, our draw loop. I've broken everything into functions because that's what we do now. So we, first of all, and so this is the new thing that we haven't seen this kind of thing before, is the first function is called handle input. So this is the function that's going to deal with user input. It's going to do whatever needs to be done if the user, in this case, uses the keyboard. And then, as we always do, we'll move the circle based on its velocity, and we'll display the circle as a circle. So what we're interested in here is this handle input function, which is this code here. And you can see that I'm using keyIsDown here. And I'm using keyIsDown to react to the arrow keys, left arrow, right arrow, up arrow, and down arrow. And this is a good little formula for one way to control something with arrow keys. So you can see we've got two sets of if statements here. The first if statement collection deals with left and right. So the first part says if the left arrow key is down, so if that's true, set the circle's velocity to a negative, so it moves to the left, corresponding to holding that key down. So if you press left, it moves left. If you're not pressing left, but you are pressing right, so else if key is down, right arrow, so you're pressing the right arrow key down. While that is happening, for as long as it's happening, set the velocity to a positive number, so it moves to the right correspondingly. And if neither of those things are true, then we'll get to the else. That means that the left arrow is not being held down and the right arrow is not being held down. So we should set the velocity horizontally to 0, so that our circle does not move horizontally. So it only moves left while we're holding down the left arrow, only moves right while we're holding down the right arrow. And then this stuff here is like exactly the same thing, right? Except it moves up and down based on the up and down arrow keys. And this is a good little template for keyboard-based controls of something that you want to move around. So if we head back to the program, there's our circle. If I press left, it moves left. I let go, it stops. If I press right, it moves right. I let go, it stops. And same thing for up and down. And this enables me to kind of steer this little circle around. I can go off the edge of the canvas. There's nothing stopping me. I could do a sneak attack and kind of go around the side here and come out from the bottom. Surprise. I have this whole ability now that the circle, I feel connected to the circle because I control where the circle goes with these arrow keys. And that's just sort of a neat thing to be able to do, and it's enabled by key is down, right? That is able to check every frame which key is being held down and to change how the circle is moving based on which key it is. And that's kind of it, right? That's what I'm going to talk about in terms of these keyboard functions. So most of all, we have the Keypressed function, which we can use to react to the moment a key is pressed down, and we have the key is down function, which we can use to react over time to a key being held down for some duration. And then along with that, we have these ideas of the key variable, which tells us which key was recently pressed that can be typed, so the R key, for example, or the C key. And then we have Keycode, which tells us the code of the key that was most recently pressed. And by that we mean the ASCII code. So 32 is space, for example. 38 is the up arrow, we know now. Or is it 40 that's the up arrow? I can't remember. There you go. That's why it's hard to remember them. And that's why it's good that P5 provides these special names for those numbers, up arrow, instead of having to remember exactly what number it is. So it's, that's the beginnings of a beautiful journey being friends with the keyboard. And I will see you in the next video. Ciao for now.